So for the lesson I designed this year, it's going to go along with my how human impact our Earth unit that I've been doing over the last couple years. First of all, I've been looking for something I could use to introduce it. I've done a lot of the things we've learned in RET in the past, but I came up with this just for an introduction to this unit. Just a little bit of prior knowledge students will need. Obviously, some safety procedures we'll have to go over. I'm using some Vernier probes that they'll probably need to be trained in before we do this activity. And then we're going to have a little bit of discussion just to get it going. So for this lesson, here's a list of required materials. Anybody interested, I have them set up over here. I'm not actually going to do the experiment today. It takes too much time. I do have a little video later on I can show you. But if you have any questions, I can share this presentation with anybody, or just come up and ask me. Here, just state objectives. This is my goal in every lesson I do. I honestly don't pay a whole lot of attention to the content standards. Our state gives us these science and engineering practices. I try real hard every activity I do to hit all of those practices right there. So hopefully they look a little familiar to everybody. Now, I know Darcy has been real big on the 5E, so I'm going to try to hit the 5E. So to start this lesson, I just found a little video on YouTube to get kids engaged. What we're going to be discussing is global warming, so hopefully I can get that to pop up. So I'm going to, that's an ad, skip that. So just what we see here is just over time, the temperature of our planet. Kind of let my plan is just to let the kids watch like 40 seconds. You can see pretty steady, pretty steady, pretty steady. And then all of a sudden in the 80s and 90s and 2000s, we see it start changing color. And there you go. So to kind of engage the students, where I'm going with this is I'm just going to ask them, what do you think just happened? What is the cause of that? And I know from experience with 8th graders, you're going to get some wild answers. There is I can't even attempt to predict what they will say. But I promise you they're going to be way off, okay? So my goal is, this is where we'll hit the explore and do the actual experiment. So I'm going to grab some of this. So this is a Vernier. I found this. It's called a Biochamber, okay? So very simple experiment, which is good for 8th graders. They don't need to be overwhelmed. But what I have is a CO2 sensor, carbon dioxide sensor, and a temperature sensor. So the first thing I do is we're gonna take a heat, like just a little desk lamp, to represent the sun. So in this experiment, the biochamber represents our planet. Okay, and actually you can kind of see I had dirt in here, made a little ecosystem inside of it. And then I turned the lamp on for 10 minutes. And we just we use the sensors to monitor the CO2 levels and the temperature. Okay? 10 minutes, and then I do the exact, after the 10 minutes, we record our data. After that, we do it again. But I took a deep breath and just blew inside it to increase the CO2 levels. Now, I understand it's not realistic. When I looked into Dr. Nanny, what is the average CO2 level on the Earth right now, roughly?
I think it's about 420.
Okay, so that's what I found, about 400 roughly parts per million. Is that correct? Okay, when I took a deep breath and blew in to my chamber, the level went to 20,000. So again, not realistic, but proof of concept, okay? So I ran the exact same experiment with a much higher level of CO2, and guess what I noticed? pull that back up. Uh-oh. Okay. This is just me running the experiment in my little apartment. I've crammed 10 minutes into 30 seconds. I'm not going to show that whole thing. But here was my data. So the first time, low CO2 levels, you can see there at 575 parts per million, which was a little high, more than likely because it was indoors, if I had to guess. My beginning temperature was 75.8 degrees Fahrenheit. My ending temperature after 10 minutes was 79.7. Okay. After blowing in, you can see I started out at 75.9, ended at 80.5. And I guess I have a lot of experience with 8th graders. 8th graders are going to look at me and say, that's not even that big a deal. But after 10 minutes, that's a pretty big deal. That's a pretty big increase for 10 minutes. More than half a degree. So then, that's day 1, do the experiment. Day 2 is the explain part of the 5 E's. So I would print each student's data that they get from the Vernier probes, work together in groups, and give a brief explanation of what happened and why they think it happened. Okay, day 3, and I do this with every activity I do. Students write a conclusion. It's not necessarily a conclusion, it's how they write what they think they've learned. It's my way to see, did we just play around for 3 days, or did they actually learn something? And I usually give them a few questions to guide them in their conclusion. So 3, okay, based on evidence from the experiment, explain how humans play a role in global warming. If humans are negatively impacting our environment through global warming, what is a possible solution? And then I have this question in almost every experiment I do. If we were to do it again, how would you change it for more accurate results? What I'm hoping to get from them there, one answer I'm looking for is let it run for longer than 10 minutes to see if there's a bigger gap in the temperature difference. And then the elaborate, like I said, this is just introductory. Then we're going to jump right in to the other, as a matter of fact, I do that windmill blade experiment as part of my unit. And I also do a fish and electric houses unit, all that I've got from the RET program. So, and that pretty much sums it up for me. Anybody got any questions? All right.